When the Artemis II spacecraft swept over the moon's south pole on April 6, 2026, the astronauts on board described something scientists have spent years struggling to capture with flat photographs and data charts. Elevation swings larger than Mount Everest. Terrain so extreme that no image, no rendering, no simulation comes close to what it actually feels like to look at it. And beneath all of that, 300 kilometers down, there is something that should not be there. Something physicists say cannot exist. Something that should never have survived the impact that created it. And yet NASA's instruments have detected it, clearly and repeatedly. It's down there, massive, dense, pressing the lunar surface downward from the inside. And in 2028, the first astronauts to set foot on the moon in over half a century are going to land directly on top of it. Without knowing what it is, there are two possible explanations. One rewrites everything we thought we understood about how the moon was born. The other means there is an entire asteroid, its metal core completely intact, buried 300 kilometers beneath the surface. Suspended there for 4 billion years. Motionless. Waiting. This is what NASA found. And this is what nobody has fully explained to you yet. Before we get to what's down there, you need to understand where this is. Because the location matters just as much as the thing itself. At the moon's south pole sits the largest confirmed impact crater in the known solar system. Not just on the moon, in the entire solar system. It's called the South Pole Aitken Basin. It measures roughly 1,600 miles across. To put that in terms that actually land, if you dropped it over the continental United States, it would stretch from the Atlantic coast to the Pacific coast, the entire country, buried under a single crater, and it reaches 8 miles deep into the lunar surface. 8 miles straight down. It was carved out 4 billion years ago when something of nearly incomprehensible size slammed into the moon at such extreme velocity that scientists still cannot accurately model the impact using modern computer simulations. The numbers keep breaking the models. Whatever struck the moon that day was massive enough to split it open. It exposed the lunar mantle, geological layers that are normally buried under hundreds of miles of crust, suddenly laid bare. Think about that. An impact so violent it cracked the moon from the inside out. And what came from that interior is still down there. At the bottom of that basin, 300 kilometers beneath your feet, is something that shouldn't have made it through. But it did, and nobody knows why. In 2019, a research team at Baylor University in Texas was doing something that sounds almost routine on paper. Cross-referencing two datasets. On one side, topographic maps of the moon produced by NASA's Lunar Reconnaissance Orbiter, a satellite that has spent over a decade measuring the height of every point on the lunar surface with millimeter precision. On the other side, gravitational data from the GRAIL mission. GRAIL was a pair of satellites NASA placed in lunar orbit in 2011 with one specific purpose: not to photograph the surface, not to map the craters, to measure gravity. The two spacecraft flew in tight formation, one trailing the other. The distance between them shifted slightly depending on the gravitational pull of whatever lay beneath them at any given moment. More mass below the surface meant stronger gravitational attraction. Stronger attraction meant the lead satellite accelerated, just barely, just measurably, before the second one reached the same spot. It was a way of reading the moon's interior without drilling into it, seeing what's inside by measuring the gravity that bleeds outward. When the Baylor team overlaid the topographic data with the GRAIL readings, something didn't add up. The floor of the South Pole Aitken Basin should have had a predictable gravitational signature. Calculable, expected, consistent with the visible terrain. But the actual gravity was far stronger than the models said it should be. Something beneath the surface was pulling downward with a force that the visible geology simply could not account for. Something heavy. Something enormous. Something the maps couldn't show because it was sitting 300 kilometers underground. Lead researcher Peter James described it this way. Imagine taking a pile of metal 5 times the size of the big island of Hawaii and burying it beneath the surface. That's roughly the amount of unexpected mass we detected. 5 times the size of Hawaii, made of metal, buried, invisible from above. And this mass wasn't just sitting there quietly. It was doing something that could be measured directly. It was pulling the basin floor downward by more than half a mile. Whatever is down there is so heavy that it's actively deforming the surface of the moon, bending it downward with the equivalent force of billions upon billions of tons. It has been doing this for 4 billion years, without stopping. When James and his team published the study, something unusual happened, something that rarely occurs in planetary science. There was no consensus, no obvious explanation that everyone could agree on. There was silence, and then there were 2 hypotheses, 2 possible explanations. Both of them, in their own way, are hard to accept. The first is the asteroid that didn't die. When the object that gouged out the South Pole Aitken Basin struck the Moon 4 billion years ago, it was moving at tens of thousands of miles per hour. An impact at that speed typically destroys the impactor completely, vaporizes it, scatters it into millions of fragments that blend into the crater's geology and disappear forever. But the Baylor team's computer models revealed something no one expected. Under very specific conditions, if the object was large enough and arrived at precisely the right angle at precisely the right speed, its metallic core might not have been destroyed. It wouldn't have survived as a solid, intact rock. Instead, it would have transformed into a dense cloud of liquid metal that, rather than escaping into space, sank down through the lunar mantle, layer by layer, mile by mile, until it stopped and solidified, 300 kilometers deep, like a bubble of metal frozen in time. If this is correct, what's buried down there is the corpse of the object that almost destroyed the Moon. A killer entombed inside its victim for 4 billion years. That's what the data suggests. But the second hypothesis doesn't have a killer, it has a ghost. When the Moon first formed, 4.5 billion years ago, it wasn't the solid, silent world we see tonight. It was a magma ocean, a planet on fire. And as that ocean cooled and crystallized over millions of years, the heavier minerals sank toward the interior. This is exactly what the models predict. It's how planetary bodies are supposed to behave. But some scientists believe that at the South Pole specifically, that process didn't happen evenly, that an unusually dense concentration of heavy minerals accumulated at that exact location, that it never redistributed the way it should have, that it got trapped, and that it has been there since the Moon's very first moments as a solid world. It's not the scar of an impact. It's a relic of the Moon's birth, a remnant from the very instant our satellite solidified into existence. 2 hypotheses. No answer. And James himself captured that uncertainty in the study with a kind of scientific honesty that hits harder than any confident conclusion. Whatever it is, wherever it came from, it's there. Now here's the part that turns this mystery into something unlike any other mystery in space. For decades, the South Pole Aitken Basin existed purely as a subject of study. A dataset, a set of coordinates on a map. Fascinating, deeply strange, and completely out of reach. That changed on April 6, 2026. On that date, the 4 astronauts aboard Artemis II flew over the eastern rim of the South Pole Aitken Basin. They were the first human beings to ever see that terrain with their own eyes. Not in photographs, not in rendered models, not in data. With their own eyes, through the windows of the Orion capsule. David Kring, the scientist who spent months training the crew in lunar geology, had been trying for years to convey what that terrain actually looks like using flat images. The words always fell short. The photos never captured the scale. But as the astronauts narrated what they were seeing in real time, Kring said something that summarizes the moment better than any scientific data point could. He said he could finally hear someone describe that terrain as a real place. Not a model, not a data set. A place. A place that human beings were approaching for the first time. And not just to look at it from a distance. Because Artemis IV, currently scheduled for 2028, has the lunar South Pole as its primary target. The same South Pole where that buried anomaly has been waiting for 4 billion years. The Artemis IV crew will walk across the surface of the basin. They'll collect rocks from terrain that something enormous warped 4 billion years ago. They'll stand on ground that is being deformed from below at this very moment. And they'll bring with them the instrument that may finally answer the question no satellite has been able to resolve. It's called LEMS, the Lunar Environment Monitoring Station, a seismometer designed specifically to probe the Moon's internal structure. The first one ever deployed at the South Pole, positioned directly above the anomaly. When it's activated, the seismic waves it records will travel through whatever is buried down there. And how those waves behave, how they bend, slow down, or accelerate as they pass through, will be different depending on what the object actually is. A metallic asteroid core will produce one specific seismic signature. A dense mineral accumulation from the Moon's formation will produce a completely different one. Within its first few hours of operation, LEMS could hand us the answer that 4 billion years have kept hidden. But there's one more layer to this story that most coverage has missed entirely. The South Pole Aitken Basin is 4 billion years old. That means it formed during the Late Heavy Bombardment, the most violent chapter in the history of the inner solar system. A period when Jupiter and Saturn shifted their orbits and unleashed a cascade of asteroids across every rocky world in their path. The Earth, Mars, the Moon, everything in range. That bombardment lasted for tens of millions of years. And during that window, something large enough to carve a crater the size of the continental United States crashed into the Moon. The same moon that has hung in our sky for 200,000 years of human history. The same satellite we've watched, mapped, and walked on without ever knowing what it carries inside. The Earth absorbed those same impacts during the same era. But the Earth has an atmosphere, oceans, plate tectonics. All the forces that make Earth habitable also erase its oldest geological history. The Moon erases nothing. The Moon preserves everything exactly as it was left. And at the South Pole, 300 kilometers down, the most complete surviving record of that violent period, in any body near our planet, is sitting in the dark. Understanding what's down there isn't just about the Moon, it's about reading the oldest chapter of Earth's own history, written in the interior of another world, waiting for someone to come and read it. And in 2028, someone is going to. 2 astronauts will descend to the surface of the lunar South Pole. They'll stand in the most ancient, most extreme environment any human being has ever set foot in, with an anomaly the mass of 5 Hawaiis sitting beneath their boots, with permanently shadowed craters plunging to 400 degrees below zero just beyond the ridge, with ice billions of years old locked inside that darkness, and with a seismometer switched on. Listening. What LEMS detects in its first hours of operation could be the most significant scientific finding about the Moon since Apollo 11 touched down. Or it could open questions we don't yet know how to ask. That happens in science too. Sometimes the answer is stranger than the question. Artemis IV reached the South Pole with 4 human eyes. It saw the terrain for the first time. It described what no photograph had ever been able to capture. And what those astronauts described left even the scientists speechless. In 2 years, 4 more astronauts are going back. This time they won't be flying over, they'll be landing, walking, turning on the instrument, and placing their weight on something that has been waiting 4 billion years to be found. I want to leave you with one question. If LEMS detects, within its first few hours, that what's buried down there is the intact metallic core of an asteroid that survived a collision 4 billion years ago, what do you think that changes about how we understand the universe? What does it mean that something could survive that? Leave your answer in the comments. And if this video made the universe feel a little stranger than it did this morning, the next one is already waiting on the channel. Because there's more. Artemis II brought back imagery of the eastern rim of the South Pole Aitken Basin that geologists are still working through. Photographs of terrain no one had captured from that angle, at that resolution, in that light. And in some of those images, there are geological details at the South Pole that could shift our understanding of exactly where the anomaly sits. How close it comes to the surface. Whether there are visible signs, from above, of what's happening miles below. Scientists are going to be analyzing this data for months, and some of what they find will almost certainly change the conversation about what's buried there, about how strange it really is, about why the gravity at that one specific point on the South Pole is so unlike anything else we've ever measured on the Moon. Artemis II's opened the door, Artemis IV is going to walk through it. And what they find on the other side of that door, beneath that surface, inside that anomaly, could be the strangest thing humanity has ever encountered on another world. Or it could confirm that the universe runs on rules we still don't fully understand. Either way, in 2028 we're going to know more than we do today. And what we know today is already strange enough to keep you up at night. Something is buried under the Moon that shouldn't be there. It has been there for 4 billion years. No one has been able to explain it. And in 2 years, humans are going to be standing directly on top of it, for the first time in history.